So what is everything really made of? I mean, if you could zoom in and in and in, what would you find at the very bottom? Well, today, we're going to become detectives and travel back in time to crack one of the biggest mysteries in the history of science.
All right, let's kick things off with this super simple question. You take some water, you add energy, what happens? Yeah, you're probably thinking, duh, it boils, and you're not wrong. But here's the twist. It turns out how you add that energy, well, that changes everything.
You know, this was the exact puzzle that had scientists in the 1800s totally stumped. Think about it. You boil water with heat, you get steam. Okay, that's still just water, right? Just in a gas form. But if you zap that same water with a bit of electricity, you get two brand new gases that were nowhere to be seen before. How in the world does that work? Same water, totally different results.
So, meet our detective on the case, a guy named John Dalton. Now, Dalton wasn't some big-shot scientist in a fancy lab. Nope. He was a school teacher who was just completely fascinated by the weather and the air around him. He was always trying to figure out how things worked. I mean, this guy would climb mountains just to study the air. And all that investigating led him to a huge breakthrough. He figured out that air isn't just, well, air. It's actually a mix of a bunch of different gases. And that got him thinking. If these gases are different, then the tiny little bits they're made of must be different too. Makes sense, right?
And that thought process brought him right back to that water mystery. Okay, so if you can zap water and get two completely different gases, what does that say about a single particle of water? Maybe, just maybe, a water particle wasn't the smallest thing after all.
And this is where he had his massive, world-changing idea. He suggested that everything is made of these teeny tiny fundamental pieces. He called them atoms, which is an old Greek word for something you can't cut up any smaller. These atoms, he said, were the ultimate building blocks of the entire universe.
So check this out. Here's how Dalton solved the water puzzle. A particle of water, he said, isn't the final story. It's actually what he called a compound, which we'd now call a molecule. It's made of even smaller bits, atoms, that are all stuck together. His first guess was that one water particle was made of one hydrogen atom and one oxygen atom.
So here's what's really going on when you zap water. That jolt of electricity is like a little hammer that cracks the water molecules open. Pop! It breaks them apart into their individual hydrogen and oxygen atoms. And once those atoms are free, they can find new partners and rearrange themselves to build totally new things, like hydrogen gas and oxygen gas. And that whole process of breaking up and rearranging, that's what a chemical reaction is all about.
And then Dalton had another aha moment. He realized, wait a minute, if you can break things apart into atoms, that must mean you can also build things with them. It's a two-way street. Atoms are basically the universe's ultimate Lego set. Just look at this. On the left, you've got the basic atomic bricks that Dalton first started working with. And on the right, that's just some of the incredible stuff he figured out you could build using just those few pieces. We're talking about things like the gas from a swamp or even sugar. It's amazing. All that complexity built from just a few simple parts. And this was the revolutionary heart of his whole idea. It totally changed science forever. See, the world isn't made of a bazillion different kinds of special particles. Nope. It's made from just a handful of different types of atoms, all snapped together in different combinations. Okay, here's a real mind-bender for you. Dalton figured out that sweet, yummy sugar and sour, tangy vinegar are actually made of the exact same three atoms: carbon, hydrogen, and oxygen. How is that possible? Well, it's all about how many of each you use and the way you arrange them. That's just how powerful these atomic building blocks are. But wait, our detective story isn't quite finished. Let's rewind a bit, back to Dalton's original model for water. Remember? He was pretty sure it was just one hydrogen atom stuck to one oxygen atom. He was so close, but he was missing one crucial clue. Because here's the thing about science. You've got to follow the evidence, wherever it leads. And pretty soon, a new piece of evidence popped up from that water zapping experiment, and it just didn't fit his model at all. So here was the new clue. When scientists got really precise and measured the amount of gas coming from the zapped water, they found something weird. They always, and I mean every single time, got exactly twice as much hydrogen gas as they did oxygen gas. The evidence was crystal clear. If water was really 1-to-1,
You should get equal amounts of both gases. But they weren't. They were getting 2 parts hydrogen for every 1 part oxygen. There was no denying it. Something about the model was wrong.
And honestly, this is the coolest part about science. It's not about being right all the time. It's about getting it right. When new evidence shows up that doesn't fit, you don't ignore it, you change your model. Scientists realize the only way you could possibly get a 2-to-1 ratio is if every single water molecule actually has 2 hydrogen atoms for every 1 oxygen atom. You know it, H2O. The evidence forced them to make the model even better.
Dalton's idea just blew the doors open on a whole new way of understanding the world. So, he started with just a few types of atoms. How many have we actually found in nature since then? What's the grand total? 94. That's it. That's the number. There are only 94 different kinds of natural atomic Legos, and those 94 bricks are what build everything. The phone in your hand, the air you're breathing, the farthest star in the sky, all of it. We went from Dalton's original handful all the way to 94. And that, right there, is the legacy of that curious schoolteacher. These 94 simple atoms are the recipe book for the entire universe. And now that we know what the ingredients are, it makes you wonder, doesn't it? What amazing new things are we going to build with them next?